Good morning, students. This is next topic in structure of atom chapter. The topic is Bohr's atomic model. Bohr's atomic model. This theory was proposed by Niels Bohr. That means he was the scientist to propose this model. Here some postulates are there. That means he told some points. Postulates means what they said. Here the points are, first point, the electrons revolves around the nucleus in circular paths are called orbits or are shells. That is the first point and very important point. The electrons revolves around the nucleus in circular paths are called orbits or shells. That means, see, this is nucleus. I told you already, nucleus contains protons and neutrons. That protons having positive charge, that is why nucleus having positive charge. That is the notation of nucleus. These are circular paths. These are circular paths. These are circular paths. So what he was telling, what he said, the electrons revolves around the nucleus. This is nucleus. Around nucleus, electrons are revolved in those circular paths. Now those circular paths are called orbits. Orbits. One more name for this is called shells. And one more name for this is called energy levels. All are same. These circular paths are called what? Orbits or shells or energy levels. What he said? Electrons revolves in these orbits. Electrons revolves in these orbits. Next, second point. The electrons revolves in these orbits. They don't lose or gain energy, so these orbits are called stationary orbits. That means when the electrons revolves in these orbits, they never lose energy and they never gain energy. That is why these are called stationary orbits. Next, these are represented by K, L, M, N, or are 1, 2, 3, 4. That means these orbits are represented by K, capital letters K, L, M, N, O, like that, or simply 1, 2, 3, 4, so on. So that means this is the first orbit. This is the first orbit, nothing but K. This is second orbit, nothing but L. This is the third orbit, nothing but M. This is the fourth orbit, nothing but N. Like that, so many orbits are present in atom. Infinite orbits are there. Next, shells contain, that means these orbits contains subshells, not substance, subshells. Subshells. They are S, P, D, F, etc. So this is also very important point. Here these are the shells. These shells contains some more substances. Those substances are called what? Subshells. They are represented by S, P, D, F, etc. For example, first shell contains only one subshell, that is 1s. This is the subshell. Second shell contains two subshells. They are 2s and 2p. Third shell contains three subshells. They are 3s, 3p and 3d. Fourth shell contains four subshells. They are 4s, 4p, 4d and 4f. Similarly, fifth shell contains 5 subshells. They are 5s, 5p, 5d, 5f and 5g. That means what is the point here? The number of subshells present in given shell is equal to shell number. I repeat once again, the number of subshells present in given shell is equal to shell number. If shell number is 1, then it contains only one subshell. If shell number is 2, then it contains 2 subshells. If shell number is 3, then it contains 3 subshells. So what are the subshells? S, P, D, F. So first shell contains one subshell, that is 1s. These are very very important point, please remember. Second shell contains 2 subshells, they are 2s and 2p. Third shell contains 3 subshells, they are 3s, 3p, 3d. All these are subshells. We cannot represent subshells in this diagram. You have to remember, these are the circular paths, those are called orbits. Again, those orbits contains subshells. Next, the number of subshells in a given shell is always equal to shell number. Just now I discussed already. S subshell contains only next, again these subshells contains orbitals. These subshells contains orbitals. Shells contains subshells contains orbitals. S subshell contains only one orbital. P subshell contains 3 orbitals. D subshell contains 5 orbitals. And F subshell contains 7 orbitals. I repeat once again, S subshell contains only 1 orbital. P subshell contains 3 orbitals. D subshell contains 5 orbitals. F subshell contains 7 orbitals. Don't get confusion, children. Listen carefully, watch it carefully. These are circular paths, those are called shells. Shells contains what? Subshells. These are subshells. Again, subshells contains orbitals. So S subshell contains how many orbitals? 1 orbital, that's all. P subshell contains 3 orbitals. D contains 5 orbitals. F contains 7 orbitals. Next, the number of orbitals present in a given shell is n square, where n is orbit number. I told you already here, the number of subshells in a given shell is orbit number, but the number of orbitals present in a given shell is n square, where n is orbit number. For example, take shell 1, first shell. It contains 1 subshell, that is 1s. It contains how many orbitals? 1 orbital. Suppose shell 2, second shell. It contains how many subshells? 2 subshells. They are 2s, 2p. Here how many orbitals? 4 orbitals. How can we say that? Because s contains 1 orbital, either 1s, 2s, 3s, 4s. Any s contains 1 orbital. Any p, 2p, 3p, 4p, any p contains 3 orbitals. So 1 plus 3, how many? 4 orbitals. Shell 3 contains 3 subshells. They are 3s, 3p, 3d. It contains how many orbitals? S contains how many? 1. P contains 3. D contains how many? 5. Total 9 orbitals. Shell 4. That means fourth shell contains how many subshells? 4 subshells. They are what? 4s, 4p, 4d, 4f. How many orbitals here? How many orbitals? 4s contains 1 orbital. 4p 3, 4d 5, 4f 7. Total 7 plus 5 12, 12 plus 3 15, 15 plus 1 16. 16 orbitals. So what is the important point? Finally, shell 1 contains 1 orbital. Shell 2 contains 4 orbitals. Shell 3 contains 9 orbitals. Shell 4 contains 16 orbitals. So what is the final statement here? The number of orbitals present in a given shell is how much? N square, where n is orbit number. So n square is it indicates what? Number of orbitals. Number of orbitals. Orbit different, orbital different. Orbit means circular path, orbital different. Number of orbitals present in given orbit or shell. For example, shell 1, how many orbitals? Put 1 here, 1 square, that means 1 orbital. Shell 2, how many orbitals? 2 square, that means 4. Shell 3, how many orbitals? 3 square, that means 9. Shell 4, how many orbitals? 16, that means 4 square, like that. So this is the formula to calculate number of orbitals present in a given orbit. The number of subshells present in a given orbit is orbit number, nothing but n. This is the formula to calculate number of subshells present in given shell or orbit. So orbit and orbita both are not same, friends, both are different. Next, we discussed just now. First shell contains 1 orbital, second shell contains 4 orbitals, third shell contains 9 orbitals, and fourth shell contains 16 orbitals. Next, one more point. This is also very important point. Each orbital contains 2 electrons. Remember carefully. Each orbital contains 2 electrons. Each orbital contains 2 electrons. S subshell contains maximum number of electrons 2, because S subshell contains one orbital that contains 2 electrons. P subshell contains maximum number of 6 electrons. P subshell, because P subshell contains how many orbitals? 3 orbitals. We discussed it already. See here, P subshell contains 3 orbitals, so that P subshell contains maximum number of 6 electrons. Each orbital contains how many? 2 electrons. And D subshell contains how many orbitals? 5 orbitals. So 5 into 2, 10 electrons. And F subshell contains how many orbitals? 7 orbitals. So that F subshell 7 into 2, 14 electrons. So these are the electrons. Here one more important point is that the maximum number of electrons present in given shell is 2n square. The maximum number of electrons present in given shell is 2n square. That means, for example, in first shell, how many maximum number of electrons? For not 2n square. That means 2 into 1 square. That means 2 into 1, nothing but 2. That means first shell contains only 2 electrons, because it contains only 1 orbital. What I told you, each orbital contains 2 electrons. In second shell, how many electrons? 2n square. Again formula, maximum number of electrons, 2 into 2 square, that means 2 into 4, that means 8, because it contains 4 orbitals. 4 2's 8. In third shell, again formula, 2n square, 2 into 3 square, that means 2 into 9, that means 18. In fourth shell, 2 into 4 square. In fourth shell, same formula, 2n square, 2 into 16, that means 32, because it contains 16. 16 to 32. So what is the here? Here 2n square is the 2n square is what? Where 2n square is indicates what? Number of electrons present in given maximum number of electrons. Maximum number of electrons present in given orbit or shell. These 3 points are very, very important. Here n is what? Number of subshells present in given shell or orbit. N square is what? Number of orbitals present in given orbit. 2n square is what? Maximum number of electrons present in given orbit. So these three are very important points. Again, these points comes in 11th class chemistry also. So what you have to understand here, this is atom. Atom contains nucleus. Around nucleus shells are present. That is the first point. Second point, shells contains subshells. Shells contains subshells. That is the second point. Third point. Next point, subshells contains orbitals. Subshells contains what? Orbitals. Next, last point, orbitals contains electrons. Orbitals contains electrons. We cannot draw subshells, orbitals, electrons in this structure because that is three-dimensional structure. So we cannot draw. I just repeat once again. Listen carefully. This is atom. Atom having positive charge at center, that is called nucleus. This is what? Nucleus. Next, around nucleus, in nucleus protons and neutrons are present. Around nucleus electrons are present. These electrons revolves around the nucleus. That is why these paths are called what? Orbits or shells or energy levels. Next point, shells contains what? Subshells. Shells contains what? Subshells. First shell contains one subshell. Second shell contains two subshells. Third shell contains three subshells. Fourth shell contains four subshells. Tenth shell contains 10 subshells. 100th shell contains 100 subshells. You have to think like that. Next, subshell contains what? Orbitals. Subshells contains what? Orbitals. What are subshells? S, P, D, F. These are subshells. Subshells contains what? Orbitals. Next, orbital contains what? Electrons. Each orbital contains maximum number of 2 electrons. There is no chance of more than 2 electrons in orbital. So S subshell contains one orbital. P subshell contains maximum 3 orbitals. S subshell contains 1 orbital. P subshell contains 3 orbitals. D subshell contains 5 orbitals. F subshell contains 7 orbitals. You have to remember all these points. Don't get confused. So, next, each orbital contains maximum number of 2 electrons. So to calculate the number of electrons, this is the formula. To calculate the maximum number of electrons in a given orbit, 2n square. To calculate the number of subshells, this is the formula n. To calculate the number of orbitals, n square is the formula. So what is the point? Atom contains shells. Shells contains subshells. Subshells contains orbitals. Orbitals contains electrons. Just like country contains states. State contains districts. Districts contain mandals. Mandal contains panchayatis. Like that, you have to think like that. Then you will get clear. So if you don't, better to watch this video twice or thrice, then you will get clear idea about this one. This is all about Bohr's theory, and this is very important theory. We will face questions mostly from this topic in CBSE level. Thank you.